Hi everyone, this is VK. Welcome to Smid World. Here I am with another video.
MIPS Maintenance Inspection Planning System check checking points, vibration, SPM, RPM, thickness, hardness, belt alignment, and track. Predictive maintenance measurements, vibration, temperature, sound, lubrication oil, process parameter, pressure, flow, and speed. Methods of diagnostics, vibration analysis, acoustic analysis, lubrication oil analysis, thermography, other NDT methods, etc. You can see here list of equipments. Item name, make, model, unit for calibration, maximum limit. What is vibration? It is the response of a system to an internal or external force which causes the system to oscillate. Vibration severity chart as per ISO 2372, machine classes and velocity millimeter per second peak. Detection by vibration analysis, unbalanced, static, couple, quasi-static type, misalignment, angular, parallel, combination, eccentric rotor, end shaft. Fourth point, mechanical looseness, structural weakness, soft foot. Fifth point, resonance, beat vibration. Sixth, mechanical rubbing, problems of belt drive machines, journal bearing defects, anti-friction bearing defects, inner race, outer race, cage, rolling elements, problems of hydrodynamic and aerodynamic machines, blade or vane, flow turbulence, cavitation, gear problems, tooth wear, tooth load, gear eccentricity, backlash, gear misalignment, crack or broken tooth. Electrical problems of AC and DC motor, variable air gap, rotor bar defect, and problems of SCRs. Frequency and amplitude. What is frequency? How many times oscillation is occurring for a given time period? It is called frequency. Units CPM, cycles per minute, or hertz. Amplitude. It is the magnitude of vibration signal. Units microns or millimeter per second or meter per second square. Physical significance of vibration characteristics. Frequency. What is vibrating? Source of the vibration. Amplitude. How much it is vibrating? Size. Severity of the problem. Phase angle. How it is vibrating? Cause of the vibration. Frequency means 60 RPM equal to 1 revolution per second equal to 1 hertz. Amplitude measurement, displacement, total distance travelled by the mass, unit is microns. Velocity, the rate of change of displacement. It is the measurement of speed at which the mass is vibrating during its oscillation. Unit millimeter per second, inches per second. Acceleration, it is the rate of change of velocity. The greater the rate of change of velocity, the greater the forces on the machines. Unit meters per second square or inches per second square. Physical significance of vibration amplitude. Displacement, stress indicator, velocity, fatigue indicator, acceleration, force indicator. When to use displacement, velocity and acceleration? You can see graph between the vibration sensitivity and frequency CPM. What is the advantage of using velocity? Flat frequency range compared to displacement and acceleration. Almost all machines generate fault frequency between 600 cpm to 60k cpm. Velocity indicates fatigue, and velocity is the best indicator of vibration severity. Scale of amplitude, you can see wave picture. Peak is called A. Peak to peak means 2A. RMS, root mean square, equal to 0.707A. Average 0.637A. Vibration transducer produces electrical signal of vibration motion. Proximity probe, displacement, velocity probe, velocity, accelerometer, acceleration. Proximity probe, you can see here picture, oil wedge. Velocity probe, coil of wire, loosely strung magnet. Phase. What is phase? Phase is a measure of relative time between two sine waves. Time delay equal to 1 by 4th period, quarter period, or equal to 90 degrees of the angle. Importance of phase. Phase is a relative measurement. Provides information how one part of the machine is vibrating compared to other. Confirmatory tool for problems like unbalance, misalignment, eccentric rotor, mechanical looseness, resonance, cocked bearing. No correlation with bearing defects, gear defects, electrical motor defects. How phase angle is measured? The phase angle is the angle the shaft travels from the shaft of data collection to when the sensor experiences maximum positive force. For example, the phase angle is 90 degree if the sensor experiences its maximum positive force at 90 degree after data collection was initiated by the tachometer. FFT spectrum analysis. What is FFT? Known as fast Fourier transformation, developed by J.B. Fourier in 1874. FFT mathematically converts overall complex signal into individual amplitude at component frequencies. Individually they will divided or divided into together. The different machinery problems cause vibration at differential frequencies. Overall vibration coming out from machine is combination of many vibration signals from various machine parts and its structure. FFT is a method of viewing the signal with respect of frequency. Spectrum analysis techniques. Step 1. Collect useful information, history of machine, control room data, speed, feed, temperature, pressure, etc. Nameplate details, bearing number, number of gear teeth, etc. Design operating parameters, critical speed. Step 2. Identify the type of measurement procedure. Identify measurement type like displacement, velocity, acceleration. Conversion of spectrums, displacement, speed in velocity, millimeter per second, acceleration, meters per second square. Measurement directions, horizontal, vertical, axial. You can see the Pummerbach picture where you need to keep the probe horizontally, vertically, axially. Manual vibration analysis. Detection by vibration analysis. There are 12 points. First one, unbalance, misalignment. Third one, eccentric rotor. Fourth, mechanical looseness. Sixth, resonance. Sixth, mechanical rubbing. Seventh, problems of belt driven machines. Eighth point, journal bearing defects. Ninth one, anti-friction bearing defects. 10th one, hydrodynamics. 11, gear problems. 12, electrical problems of AC and DC motors. Unbalance, Causes of unbalance: uneven distribution of mass of rotor, that accumulation on fan rotors, rotor eccentricity, roller deflection, especially in paper machines, machining errors, uneven erosion and corrosion of pump impellers, missing balance gauge. Type of unbalance: static unbalance, couple unbalance, overhung rotor unbalance. Static unbalance, you can see in picture clearly. Detection: highest horizontal vibration. Amplitude increases as square of speed. Dominant frequency at 1 into RPM. Horizontal to vertical phase difference 90 degrees on the same bearing housing. Correction can be corrected by one balance gauge. Vibration phase analysis: angular 180-degree phase shift in the axial direction across the coupling. Offset means 180-degree phase shift in the radial direction across the coupling. 0 to 180-degree phase shift occurs as the sensor moves from horizontal to vertical direction of the same machine. Skew: 180-degree phase shift in the axial or radial direction across the coupling. Coupling unbalance. Detection: high horizontal and sometimes axial vibration. Dominant frequency at 1 into 1x to RPM. 180-degree phase difference between the both bearings, horizontal as well as vertical direction. Correction: it requires two plane balancing. Overhung rotor balance. Detection: high horizontal and axial vibration. Dominant frequency at 1x RPM. Axial readings will be in phase, but radial phase readings might be unsteady. Correction: overhung rotors might be having both static and couple unbalance, and each of which requires correction. Misalignment. Causes of misalignment: thermal expansion, most machines align cold. Machine vibrations and forces transmitted to the machine by pipe or support structure or soft foot, and direct coupled machines are not properly aligned. Poor workmanship. Types of misalignment: offset type, angular type, skew, combination of offset and angle. Diagnosis of misalignment: vibration spectrum analysis. Angular: axial vibration at 1x RPM, offset radial vibration at 2x or 3x RPM. Harmonics: 3x to 10x generates as severity increases. If the 2x amplitude more than 50% of 1x, then coupling damage starts. Take care. If the 2x amplitude more than 150% of 1x, then machine should be stopped for correction. Misaligned or pocket bearing: predominant 1x and 2x in the axial direction. Second point, 180-degree phase shift top to bottom and or side to side of the axial direction of the same bearing housing. Bend shaft. Diagnosis: high 1x axial and high 1x radial if bend is near the center. High 2x axial and high 2x radial if the bend is near the coupling. Fourth point, the face of the 1x component 180 degree at the opposite end of the rotor. Fourth point, phase difference of 180 between left and right hand side and also upper and lower sides of the same bearing housing in the axial direction. Fifth point, amplitude of 1x and 2x RPM will be steady. Sixth point, high bearing temperature. Eccentric rotor. When center of the rotation is offset from geometric center. Second point, dominant frequency 1x. Third point, horizontal to vertical phase difference either 0 or 180 degree in the same bearing housing. Both indicate straight line motion. Resonance. Resonance when will occur? It occurs when the forcing frequency coincides with the system natural frequency. When it occurs, it causes amplitude application which results catastrophic failure. Requires changing of natural frequency or change of operating speed. Board plot is used to identify resonance. Beat vibration. It is a result of two closely spaced frequencies going into and out of synchronization with one another. The spectrum will show one peak pulsating up and down. Third point, low frequency vibration 5 to 100 cpm cycles per minute. The beat frequencies are not normally a problem when the differences exceed 150 to 200 cpm. Mechanical looseness causes. It also cannot create vibration, but in the influence of unbalance, misalignment, bearing problems, it amplifies the amplitude. It should be corrected first. Types: structural frame base looseness treated as 1x. If you got 2x, means cracked structure or bearing pedestal. Rotating looseness means loose bearing, improper fit between component parts. Structural frame or base looseness means 1x caused by structural looseness or weakness of the machine feet, base plate and concrete base. Second point, deterioration of grouting. Third point, deterioration of frame or base. Fourth, soft wood. Loose holding downwards. Analysis. Dominant frequency 1x, similar to unbalance and misalignment. Horizontal to vertical phase difference 0 to 180 degree at the same bearing housing. Third point, 180 degree phase difference in the vertical direction between two surfaces. Cracked structure bearing pedestal 2x. If it's coming 2x means caused by crack in the structure or bearing pedestals, occasionally on some loose bearing housing bolts, loose bearing or improper component fit. Analysis. 2x RPM amplitude is greater than 150% of 1x RPM amplitude in radial direction. Amplitudes are somewhat erratic. 2x RPM phase somewhat erratic. You can erase it. Rotating looseness caused by loose rotor, bearing loose in the housing, bearing loose in the shaft, excessive bearing internal clearances. Analysis. The generated running speed harmonic up to 20x RPM generates low amplitude frequency of half x, means 0.5, 1.5, 2.5 and 1/3 arcs also. Presence of half x will indicate more advanced looseness problems like presence of rub. It indicates other problems like unbalance and misalignment. Phase measurement will be erratic. Fifth point, phase for loose rotor will vary from one measurement to next. Bearing loose on the shaft will generate 1x RPM peak. Bearing loose in the housing will